All right, so now look at the last three problems, 26 through 28, on the 2008 multiple choice non-calculator. 26, you have to find the derivative of arctangent. I don't teach the derivatives of the arc trig functions, just because it's just basically more formulas that you have to memorize, and the chances of it showing up on the test, you might see it once, maybe twice. But the formula for taking the derivative of arctangent, whoops, helps if I turn the pen on. If you want to take the derivative of the arctangent of some function, it's u prime over 1 plus u squared. So in this case, u is 4x. So it would be the derivative of 4x, which is 4, over 1 plus 4x squared, which would be 16x squared. And then we would plug 1/4 into that. So we would have 4 over 1 plus 16 times 1/4 squared, which would be 1/16. So 4 over 1 plus 1, 4 over 2, or 2. The problems are not difficult. It's just 6 more formulas that you would have to memorize. They're in your textbook in the front of it if you really, really want to learn them and memorize them. But like I said, this would, if I were taking this test, I just would not have answered this one. I don't know these formulas off the top of my head. I haven't bothered to learn them because they're pretty obscure. All right, 27. 27, we have a slope field problem. And it says, shown above is a slope field for which of the following differential equations? So when I'm trying to match up a slope field to a differential equation, the first thing I look at is anywhere that the slopes are 0 or undefined. So I can see on this graph that the slopes are 0 if x is -1, and they're also 0 if y is 0. So then I look at my answer choices and see which of these would that apply to. So if x was -1 and y was 0, this could work, right? We would have, oh wait, no. Hold on, let me think about this for a second. So let's see, if x was -1, would it, yes, no, this could not be it, because let's say we are looking at the point -1, -1. If I plug in -1 for x and -1 for y, I'm looking at this point right here. Oops, oh, turn the pen on. Right here, where the slope should be 0. And if I plug it in down here, I don't get 0, I get 1. So it's not this one. Same thing on this one. If I plug in the point -1, -1, -1 for x and -1 for y, I get 1 plus 1, which is 2, so it's not this one. It could be this one. It could be this one. It could be this one. All right, so let's think about some other points. What about if I look at the point -1, 2. If I plug in -1 for x and 2 for y, do I get 0? Yes. -1 for x and 2 for y, do I get 0? No. All right, so then down to C and E. Let's look at some of these other points on here. So if I plug in 1, 0, do I get 0? No on this one. Right, if I look at this point over here where the slope's 0, that's the point 1, 0. If I plug 1 in for x and 0 in for y, well, I get 0. So that one would be C. All right, 28. Let f be a differentiable function such that f of 3 equals 15. F prime of 3 equals negative 8. F prime of 6 equals negative 2. And the function g is the inverse of f. What's the value of g prime of 3? This is another one of those formulas that I honestly do not have memorized off the top of my head. This is the formula for taking the derivative of the inverse function. This is when g is the inverse of f. So we're doing g prime of 3, so we would do 1 over f prime of g of 3. And since g and f are inverses, when I come back up here, I have a couple of ordered pairs here. These are ordered pairs on f, which means that ordered pairs on g would be the inverse. Just switch the x and y's. So g of 3 is 6. And then f prime of 6 is negative 2. So this would be negative 1/2.